My name is Juji Carminati. Welcome to the C2 Space Chronicles, where we show you the messy, uncertain, very experimental side of studying human physiology in extreme environments. This particular set of videos is going to be about understanding nitrogen narcosis, specifically understanding what does it mean to have cognitive impairment because of nitrogen narcosis. So we start with that initial statement, right? Nitrogen narcosis causes cognitive impairment. Let's break down that statement. Nitrogen narcosis causes. Generally speaking, we understand, we as divers, we as scientists, we as members of this community understand that nitrogen at higher pressures seems to be causing an effect. And I'm going to be careful to not call it cognitive, and that you're going to figure out why I'm going to be a little bit more careful about using that word, okay? So we understand that nitrogen causes an effect. And right now, the main theory, the main hypothesis is called the liposolubility theory of narcosis. And that is that at higher pressures, nitrogen gets literally pushed into our lipid cells, our lipid layers, which includes the myelin sheaths around our neurons, and that causes something. It causes some feeling, some impairment, something to happen. Now, for a while, researchers thought, well, maybe it's the lack of CO2 that causes this, and there were a certain number of studies that excluded that. And then there were other studies that said, well, maybe it's the high oxygen, right? Because air is 21% oxygen, 79% nitrogen. And so the idea was, well, maybe the oxygen at higher pressures is the thing that is causing this it factor, this thing that happens at depth. But some studies eventually said, well, we don't think it's oxygen. Although lately, certainly dive agencies, for instance, PADI, will include in their materials that oxygen and nitrogen are just as narcotic as each other. So we're going to leave that as an open question, okay? So maybe oxygen is as narcotic as nitrogen. I'm going to leave that there because that's not the subject of the study that we're conducting here. And I will tell you this, by the way, as I sit here, I have not finished the study. I have no idea where we're going to go. I have no idea how it's going to turn out. So you are on this adventure with me, with us, with our team at C2 Space. Okay, so let's start with this idea that nitrogen causes something at depth. All right, so that's point one. The thing that this study is really going to focus in on is the idea of cognitive impairment, right? What does it mean to be cognitively impaired? And what is it exactly that nitrogen is doing? Every paper, every training program, every random conversation just uses this term. Nitrogen narcosis causes cognitive impairment. But we decided that we wanted to look into it and understand, what does that mean, right? What does it mean that it impairs cognition? Is it when a person has trouble remembering things? Is it if somebody has trouble learning new things? Is it affecting a person's ability to concentrate? Is it affecting a person's ability to identify problems, to troubleshoot problems? Or is it an issue of motor functions, right? All of those things make up cognition. And this is kind of a simplistic way to talk about it. But when we say cognitive impairment, it seems like such a broad term, and it doesn't really answer questions that are related to diving because, and here's the thing, if you are underwater and nitrogen makes it harder for you to access, for example, long-term memory or short-term memory, or if it makes it harder to create memories, that's a very different conversation than if it makes it literally harder for you to make good decisions, okay? Because if I have trouble accessing my long-term memory when I'm under the effect of nitrogen, who cares, right? When I'm diving. But if I am having trouble identifying problems, troubleshooting problems, if I am less accurate in the way that I address issues, or if I am having actual motor functions, if I have hand-eye coordination issues, then that's possibly more problematic if you are looking at, does it affect my safety while I am underwater? Does it affect my ability to complete my tasks or missions or whatever it is that I'm supposed to do while I am underwater? So that was the first thing that we started narrowing in on in designing this study. So let's break it down. Cognition includes at least 4 definitions: long-term memory, short-term memory, focus, and decision making. There are other factors we would look at within those 4 domains. For instance, speed of decision making, accuracy of decision making, motor functions, the creation of memories versus the retrieval of memories. All of these are different ways that you can cut up the concept of cognition. When I say cognitive impairment, what do we mean? And more importantly, which ones matter for underwater activities, right? So for example, does it matter that I can't make new memories? Does it matter that I can't retrieve old memories? Does it matter that I make decisions that are just as accurate, but I make them slower? And if I am making slower decisions, is it a fraction of a second? Is it a millisecond? Is it 5 seconds? Is it 10 seconds? Because that would make a difference, right? And this was the big one after I finished looking at all the literature that has me really excited about this research that we're doing. What if none of it's about decision making? What if the thing that people are saying they're feeling is actually just a change in mood? And there's some very interesting papers about that, about the fact that there are differences between mood and personality versus your actual cognition. And then it hit me like, what if we're all talking about something that either makes you euphoric or agitated or angry, but doesn't actually affect your ability to make decisions? And I thought, well, that's a very interesting question, right? Like, that's something that's worth digging into. Because ultimately, being in a good or a bad mood doesn't affect your ability to do a job. Or does it? Maybe. So that's what we set out to do in this particular project. The first thing we did was that we explored study designs. And we found that there were 3 major issues that we would want to address in our particular study. And these are 3 issues that we found when we were looking at everybody else's studies on the topic, everybody else's papers. So the 3 things that we really wanted to address were, 1, that there were very small study groups. And so we want to try to create bigger subject pools, right? The second thing is that much of the studies are overwhelmingly done on male candidates for historical reasons, but it's 2023, let's get out of it. And so we really want to make sure that we incorporate as many men and women into our studies so that we can do more head-to-head studying, and we can also see female physiology underwater. Third, overwhelmingly, the studies have been in chambers. And there is very good data that being in the water is a very different experience than being dry in a chamber. And some ways people have tried to address that is, for example, by putting people in water, like in bathtubs and in containers of water, while they are undergoing the studies in the chambers. But we decided that we're going to go do our studies out in the water, like in the actual environment, which raises a whole bunch of logistical problems which we had to address, and I'm going to take you through them. So the first thing we decided is that we were going to do a pilot study underwater. And we were going to do cognitive tests, and they were either going to have to be on paper or with an electronic device. Now, you know that nitrogen narcosis occurs about 30 meters and beyond. So by definition, at least some of our testing is going to have to be at 30 meters or beyond. And when we first started working on this study, we really did not think that we would be able to take tablets or electronics to do the tests, the cognitive tests on an electronic device that deep. Now, since then, we've actually, through some, again, this is asking people, looking out there, trying to figure out, like, we need a tablet, we need a case that can take a tablet or a phone deep enough while also allowing you to keep accessing the touch screen features so you can do responsive testing, right? Because you need to be able to answer questions, you need to be able to respond and show your reflex speed. And so literally in the last 10 days, we stumbled across a case that may fit the bill. And so we have not tested it yet. So when we were first designing the study, we thought we're going to have to do it on paper, which meant that I set out and we bought a whole bunch of waterproof paper, and then we laminated paper at home to figure out if we could take it down underwater with us. And we actually found a couple good options. So we ended up selecting one paper type and then one lamination method that I was using at home. It's super simple. It's literally the stuff you buy at any store. And I put it in the pool. I put my laminated paper in the pool for like 5-6 hours, and it was great. And so that's how I tested to figure out if we could do it. Now, I keep talking to you about, okay, these tests that we're going to go do underwater. So the test that we decided to do was the DSST. And the DSST is a document, is basically a test where you have a certain number of digits that are associated with symbols, and then you are given a number of blanks with a number over it. And for each of the blanks, you have to substitute what symbol corresponds to that digit. And we agreed that we were going to do this test at the surface, so before going into the water, at 6 meters, then at 40 meters, then at 40 meters again, and then back at 6 meters, and then after we got out of the water. And that way we would be able to see if there's any difference in the cognition results that you get at what should be baseline, then as soon as you're immersed, and then once you are definitely should be under the influence of nitrogen narcosis, 10 minutes to see if exposure makes it better or worse, or if there's habituation. There's some literature that there is in fact a habituation effect. And so we wanted to see if we would think that would be a good way to try to find that. And then we would do it again at 6 meters to see if whatever effect we find, if there is one, is going away by 6 meters. And then if it resolves once you exit the water, because right now the current idea is that nitrogen narcosis resolves entirely once you're out of the water, as soon as you start ascending. So the DSST, which is the digit substitution test, is meant to measure attention, processing speed, and executive function. And given that that's one of the main domains of cognition, we thought that's a good test to start with. The way it's done is that somebody has to fill in this chart and has to get as many correct answers, so correct throughput, in 120 seconds. So it's a 2-minute test. And the other thing we look at when we're designing the study is we don't want people to be doing a 15-minute test underwater, right? That's not realistic, because you're not going to do 15, 15, 15, 15. That's just too much. So we need something that is both fast enough but accurate enough to give you the information that you're looking for. I can share with you that there were a lot of conversations about font size, font color, how big should the paper be, because we were trying to make sure that what is causing any effect is not the difficulty of being underwater, writing underwater, or the print being too small, or something else outside the DSST itself. Now, if I'm underwater and I want to fill in this DSST on waterproof paper or laminate, I have to have a writing implement. And this was actually really, really hard. So what we did is that we started, we looked at pencils, and then we looked at grease pencils. And it turns out that grease pencils worked pretty well. Not great, but it was a start, right? Like it was a start. So I bought a bunch of literally grease pencils off Amazon. And then I went to my sink and I wrote. And I tried to write symbols, and I tried to write on the laminate, and then I tried to write on the laminated paper, and then I tried to write on the waterproof paper, and I was trying to figure out what would work best. So we actually came down to 2 types of grease pencils that we took with us for our pilot study, and those were the ones that we tested out in the salt water. There was another one I tried that was a complete disaster under the tap, so I did not even bother taking out with me to the ocean. And then beyond that, we had to discuss other logistics. So do we want clipboards? And the answer was yes. How do we carry all of this gear so that it's not cumbersome and it doesn't endanger us? And we ended up using a mesh bag. And then I was thinking, well, maybe we also need a lift bag. So we brought a lift bag with a mesh bag. And then obviously we eventually want to go deeper than 40 meters, but for the pilot, we thought 40 meters is good enough because it's beyond the nitrogen narcosis threshold of 30 meters, but not so deep that we're going to get hammered with decompression obligations. And that turned out to be right. And I would note that we're doing this on a rebreather, which is why the 40 meters turned out to be just perfect. And then just as we were about to set out, it dawned on us, okay, but asking someone to do the DSST alone doesn't really give you all the answers you're looking for. We also wanted to know how they were feeling. And we spent quite some time looking at different papers and trying to understand how, is there formalized way of asking people how they feel. And it turns out there is a feeling wheel, an emotion wheel. And so we incorporated that on the back of the DSSTs, and we asked people to self-report their emotion, the strength of that emotion from 0 to 4, whether they thought they were experiencing nitrogen narcosis, and that was yes, no, not sure. And then we asked them to self-report their depth and their dive time. And the reason we picked those two factors is because in a safety situation, we thought, what are the two things that you really need to know if you're facing danger, or that really are meant to preserve your safety? And I thought knowing how long you've been diving and knowing at what depth you are probably the two big things that you need to be able to read off your computer accurately. So we went ahead and picked those. And we included the fact that we wanted the subjects to tell us answers to that, both before and after they take their test, because I wondered whether they would have a different opinion of whether they had nitrogen narcosis after they took the DSST. So their perceived sense of if they did well or not well. And so I incorporated that too. So the test ended up being the emotion wheel with 0, 1, 2, 3, the self-report of narcosis, depth, time, and then they did their DSST for 120 seconds. And then they started all over again with that little emotion wheel, depth, time, and self-assessment of narcosis. And there we had it. That was how we came up with this pilot design. So the testing goals for the pilot were going to be figure out if grease pencils work, figure out if we want to use underwater waterproof paper or laminated sheets, how do we transport all this stuff, and does any of this work at all? Like, did we forget something? Did we miss something? Is it even feasible? Will it work out? So that's how we set out. And so then we headed to Bonaire. I know, hard life. You know, this is hard stuff. Well, we had a conference plan, and so we went ahead and did it during that. And so in the next video, I will tell you how it actually went. And again, thank you for watching. My name is Juji Carminati. These are the C2 Space Chronicles.